Go.
Agile Blast!
Guys, where's the robot?
We ordered the parts 2 months ago, they still haven't came.
What? The competition's in 3 days. What are we gonna do?
Judges, why are we telling you this? Believe it or not, this was us 3 months ago.
Hello, we're Team HR Blast 26936. Our team is comprised of 3 two-year veterans, and then the rest 7 are rookies. Agile Blast means to be agile, or adapt to our situations, and blast with our full effort. This year, our team motto is, if it doesn't challenge you, it doesn't change you. And this year, we were challenged by making a fully custom robot, migrating to Android Studio, and ambitious outreach.
Forgot the name.
When designing the robot, we use the engineering design process. The engineering design process includes identifying the problem, creating solution, prototyping, and then iterating and again.
At the kickoff event, we immediately started brainstorming ideas that we could do to solve this year's problem. We originally wanted to use a spin indexer to sort the balls according to the motif pattern. To do this, we started immediately CADing using the engineering design process.
From this, we improved our spin indexer by changing the radius, speed, and arc of it. However, it didn't quite give us the results we wanted. Due to this, after much research, we finalized on a direct transfer shooter. This would intake the balls and shoot them directly through a transfer system. There's a trade-off. We wouldn't be able to sort balls, where our cycle times would be significantly faster.
For our intake, we had 3 major iterations. Our first intake had horizontal rollers just like this one, but was on a fixed point. Our second intake were vertical spinners, but we found that to be too inefficient. And our third one, as you can see here, have horizontal rollers, but on a pivoted point. This allowed for maximum traction and compliancy when intaking balls.
Over the course of the FTC season, we iterated our shooter multiple times. During the first part of our season, the shooter was made of a counter roller, which unfortunately decreased our speed significantly. During the second iteration, we used aluminum plate and flywheel system, which was more powerful but less accurate. In our final iteration, we decided to use 2 flywheels and 2 rhino wheels to keep the speed at constant rate when we're firing, and the shooter was built to be more compact and sturdy.
We have 2 cut-off gecko wheels that help transfer the artifact into the outtake that is contained by a gate. The gate is to hold the artifact so our outtake reaches max velocity. We also have an adjustable hood that lets us shoot from far away parts in the field.
For our teleop strategy, we use a single button on our controller to activate multiple parts of the subsystem. For our autonomous, since it was our first year migrating to Android Studio, we decided to use Pedro pathing. This allowed us to make an efficient 12-ball auto, as well as use vision, as you can see here with our limelight. This allows us to align precisely with the balls.
When testing a robot, we struggled with inconsistency when shooting. First ball would go in, and then the other 2 would escape. So what we used was the PIDF controller to control our progressive values, integral values, derivative values, and our feed forward. So this way, we increased our accuracy with our shooter.
As for connections, we connected with 10 FTC teams through Reddit, Discord, and in-person meetings. We discussed key points such as choosing a mechanism drivetrain over a six-wheel skid steer differential drivetrain, autonomous routines, and finally, implementing odometry into a robot.
We had also contacted many IT professionals in major corporate businesses that helped understand what the real world expects from us, such as teamwork, technological work, and communication.
We hosted multiple neighborhood events for over 300 people, K-12 students, where they were able to explore a robot and explore first. We also have we're also co-developing an 11-week program with Best Brains launching this summer. Going farther, we also talked to schools district 202 and 204 about robotics.
As for sustainability, as we are a community team, we basically start with nothing. So this year, we raised $5,000 through team member contributions and $200 from our Polymaker grant. For our future plans, we have already acquired a 501c3 not-for-profit status to Hack Club, and we've already had lasting connections with major corporations and organizations.
This season, we've developed 7 rookies into engineers and reached over 300 students and built a fully custom robot through multiple iterations of failure and learning and using the engineering design process. Every challenge has made us better as individuals, as teammates, and as members of the FIRST community. We believe if it doesn't challenge us, it doesn't change us. We're Team 26936 Agile Blast Robotics. Thank you, judges.